You're welcome to the first video of the course IP version 6. In this section, I'm going to compare IPv6 address size and components with IPv4 address, and then we will learn two IPv6 abbreviation rules which helps to make easier to read and write IPv6 addresses. As you know, IP version 4 addresses are 32 bits and offer a limited number of addresses. To resolve this limitation, IP version 6 was introduced with 128-bit formats, vastly expanding the number of available addresses. In IP version 4, addresses are presented as 4 decimal numbers ranging from 0 to 255, separated by point. In contrast, IP version 6 addresses use 8 group of hexadecimal numbers ranging from 0000 to FFFF, separated by colons, as you can see in these two examples. Each IP version 4 address is divided into two parts, the network portion and the host portion. The network portion identifies a specific network or subnet which is shared by all devices within that subnet. The host portion identifies the individual devices within that network, providing a unique address to each device in that subnet. The subnet mask is used to differentiate these parts. It specifies how many bits of the IP address here 24 are allocated for the network section, and which are, or how many bits are allocated for the host portion, which is other 8 bits in this example. Consider the IP address 192.168.1.1 with a subnet mask of /24. The subnet mask indicates that the first 24 bits of the IP address are used for network portion, while the remaining 8 bits are used for the host portion. The same concept applies to IP version 6, but with different terminology in IPv6 address. The network portion in IPv6 is referred to as prefix. The host portion is known as interface identifier in IP version 6 address, and subnet mask is replaced by prefix length in IPv6 address. As you can see, it's a little difficult to write IPv6 addresses. Writing IPv6 addresses can be simplified by applying two rules: removing leading zeros and using zero compression. Here is how these two rules works. You can, in the first rule, remove leading zero. You can remove any leading zeros in each segment of the IPv6 address to shorten it. For example, you can remove here the 0. You can here remove 3 first 0, 3 first 0, and 0. And this is the shortened version of IPv6 address resulting from applying the first rule. In the second rule, zero compression, consecutive sections of the 0 can be replaced with a double colon. This can be done only once in an address to avoid confusion. For example, in this example, we will remove 4 consecutive zeros with single double colon. So this is the compressed version of IPv6 address. Let's discuss 3 examples with applying both rules. This is the original IP version 6 address. In the first rule, we remove the leading zeros and it will be converted to this address. 30, 30, 30, and 30 here and 10 here are removed from the IP address. And then we will remove these 4 consecutive zeros with single double colon, and this is the final compressed version of IP version 6 address. And this is the second example. In the first rule, we will remove the first 0, here the first 3 zeros, the first 2 zeros, the first 3 zeros, and again here zeros, and this is the summarized version of IPv6, and in the second step we can remove this 0 or the other 0 and convert it with a single double colon, but we are not allowed to remove both 0 and convert it with double colon. Just a single 0 is removed. And the third example, this is the original IPv6 address. In the first rule, we are allowed to remove 3 first zeros, 3 first zeros, 3 first zeros, and here also the first zeros. And this is the summarized version of IPv6 by the first rule, and then we are allowed to remove these 3 zeros and replace it with a single double colon. And this is the summarized final version of IPv6 address. Once again, to emphasize, double colon notation should only be used once in an IPv6 address to avoid ambiguity. When there are multiple possible places to use double colon, apply it to the longest run of 0 segments to achieve the shortest possible address. By following these two rules, you can significantly simplify the representation of IPv6 address, making them easier to write, read, and manage.